Good evening, my name is Evelyn Tienda, and this is for class Geology1403-V01 for semester Fall 2025. My PowerPoint is titled Understanding the Smoking Giant, which is the Popocatépetl in Mexico. Now, our objective of this presentation is on the Popocatépetl is not only to condense the research papers that I utilized to have a collective purpose to study and retrieve information, but also to understand and not only become acquainted, but to understand its plumbing, volcanic ash, and explosive reconstruction. That helps us understand the volcano's behavior, assess and mitigate the possible hazards to the surrounding population and the nature, as well as to contribute to a broader field of volcanology. This information is important because the Popocatépetl is one of the most active and hazardous volcanoes in North America. Now, as far as our key points here, we need to understand, we're aiming to understand the volcanic processes. So in doing so, we are attempting to not only identify, but understand the pressure estimates in the Popocatépetl volcano in Mexico. Now, by studying that, its magmatic plumbing system, which is a network of conduits and reservoirs beneath the volcano, we can provide insights into the origin of magmas and the physical and chemical processes that govern the eruptions. We're also looking at the high temperatures of volcanic ash on Yttria stabilized zirconia. And pretty much what we're hoping to do with this is serve to synthesize complex scientific data from thermal heating and cooling cycles to assess not only its mercury, but also to help forecast any changes in eruptive behavior, such as the transition of effusive lava flow to explosive activity. Now, as far as mercury specifically, we're hoping to communicate it to other researchers, students, and authorities in the public. It is an integrated approach to the comprehensive understanding of the volcano structure and substantial risk of high performance ceramic coatings at elevated temperatures and presented by volcanic ash. Now, by reconstructing the eruption reconstruction history of Central America, by reconstructing the volcano's eruptive history, we're hoping to include the past ash dispersal patterns as well, and the dynamics of explosive events. Now, scientists can use this when they recreate the hazard maps, and define possible future eruptive scenarios. Now, this information should help civil protection authorities establish effective evacuation protocols and a long-term planning to minimize the impact on local communities. Now, the following slide is a pressure estimates in volcanic plumbing system. Now, in an attempt to estimate the pressure and depth of magma storages in the Popocatépetl volcano in Mexico, two particular methods of geoparameters are compared. The first is the NIMIX. It's developed in 1999, which requires both the chemical composition, which is obtained by analyzing electron microprobe, and is coupled with data from single crystal X-ray diffraction. And the second one, which is a Nieve and Piturca, is developed in 2017, relies solely on the chemical composition from electron microbe analysis. Now, the NIMIS uses both the chemical composition, and which is the fundamental input of the data, and the understanding of crystal structure, which is the physical basis for the calculations. Now, using the Nieve and Piturca alone, it did result in a little bit of difficulty identifying the chambers, which would have been your I'm sorry. Yes, there was a struggle to accurately estimate the magma crystallization depths in the complex volcanic systems with just the neve alone. So when we use the NIMES, the study combines the crystal structure parameters, which is cell and M1 site volumes from X-ray diffraction, with chemical composition data, and that condensation of the methods showed a strong correlation between crystal volume and estimated depths, which more or less resembled what the estimates, and it also successfully distinguished the 3 distinct magma reservoirs in the Popocatépetl plumbing system. So the reservoirs were identified at approximately 30 kilometers, 18 kilometers, and 0 to 10 kilometers below sea level. That approach, condensing both methods, provided a more robust method for understanding the architecture of volcanic plumbing systems, and it enhanced volcanic hazard assessment by accurately locating the magma storage layers. And we can see on the graph, we can see a little bit of its plumbing. As far as the volcanic ash interacts with yttria stabilized, now the study interacts of 7YSZ ceramic used in jet engines, which with volcanic ash at a 1350 degrees Celsius methodology. That's what we're hyper focusing on right now. So the volcanic ash from 2 locations is deposited on ceramic coupons. Pretty much okay, on ceramic coupons, and the samples expose 8 heating and cooling cycles of 8 hours each. Now, this paper investigates the crucial issue of material degradation in high temperature environments. So specifically focusing on the interaction between volcanic ash and the ceramic coating used in critical applications like jet engines. The primary goal was to evaluate the durability of yttria stabilized zirconia, which is that Y7SZ ceramic material when it's exposed to the Popocatépetl volcanic ash at the extreme temperature of 1350 degrees Celsius, which would be mimicking a real world engine condition. So researchers did collect volcanic ash samples from 2 different locations and deposit them onto the surface of the Y7YSZ ceramic coupons, which is the yttria stabilized zirconia. These samples underwent 8 rigorous heating and cooling cycles. What came of those cooling cycles is a thick layer of molten ash formed on the ceramic surface. The melted ash aggressively infiltrated the fine grained microstructure of the ceramic, and the overall effect was a complete failure of the material, characterized by the development and propagation of large cracks throughout the substrate. So the study pretty much concluded that the volcanic ash presented a substantial risk to high performance ceramic coatings at an elevated temperature, leading to a rapid degradation and material failure through the formation of new and brittle compounds. Now, for our mercury concentration in volcanic ash, so essentially it's an assessment of evaluate mercury concentrations in ash. So compare that to global data and assess the contamination and health risks it might have. The methods they utilized were the ICP-MC and DMA-80 analytic techniques on volcano ash samples. The findings, of course, were DM-80 provided more accurate results due to fewer matrix interferences than ICP-MS. Our HG levels, average HG concentrations were low. Pollutant indices indicated very low environmental contaminations, and Health risk assessments showed minimal health concern for adults and children. The hazard index remained below the risk threshold of 1. Now, in the 2023 Popocatépetl ash post a low risk under current exposure scenarios. Continuous monitoring is warranted as future volcanic activity may influence emission levels. Now, pretty much what it was is it was an assessment of mercury concentrations in volcanic ash from the 2023 eruption of the Popocatépetl volcano in Mexico. What they set out to do essentially was to evaluate environmental contamination levels and what potential health risks might be associated with the propagation of the ash. All in all, the health risks were below the risk threshold of 1. We also set out to reconstruct one of the volcano's explosions. Well, several. But this next slide is explosive reconstruction of central Mexico. So this is the Sierra Nevada volcanic range, pretty much. So in order to provide an understanding long-term, middle to late Pleistocene explosive eruption record for the Popocatépetl, the Iztaccíhuatl, and the Tlalpan volcanoes, they used detailed tephrostratigraphic surveys, a new 40 AR-39 AR geochronological analysis, and glass geochemistry was utilized to characterize eruption units and identify their sources. So as far as the Iztaccíhuatl history, it produced at least 6 explosive rhyolitic eruptions since 63144 Ka, but activity ceased between 600 and 500 Ka. The Popocatépetl has produced at least 27 medium to large explosive eruptions and adenistic and dacitic composition since the Iztaccíhuatl cessations continuing to the present day. The new data does improves the understanding of eruption frequency and scale, which is crucial to better assessing volcanic hazard to the dense population of Mexico. Now, all in all, we are trying to fill in knowledge gaps that are regarding the long-term eruption history of the Sierra Nevada range, and improve volcanic hazard assessments for Mexico City as a whole. So the study is using the advanced techniques, including the 40 AR-39 AR, geochronology, and the glass geochemistry on 2 extensive tephra sequences. So although the Popocatépetl, since the Iztaccíhuatls ceased, it's been significantly active. As mentioned before, it has at least 27 medium to large explosion eruptions, a history that continues because it's still very active to present day. Now the data provides a critical information on the frequency and the magnitude of past eruptions, which directly informs current risk assessments for the heavily populating surrounding areas. I would like to add that the new data also improves understanding on eruption frequency and scale with the which is very important for better assessing volcanic hazard to the dense population of Mexico City. Now, final tips and takeaway, which is our conclusion and our wrap up. The initial objective of this presentation wasn't only just to understand the volcanic mechanisms, which was essentially to identify and describe how the volcano's internal plumbing system works, analyze its eruptive behavior and its products, what comes of said behavior and eruptions, which is to describe the characteristics, its dispersal, and impact of volcanic ash produced by the Popocatépetl's explosive eruptions, reconstructing its eruptive history, as to try and explain how geological evidence, historical records, and ash distribution maps are used to reconstruct the volcano's history of edifice construction and destruction. All in all, we're just trying to assess and mitigate the risk, to highlight the scientific monitoring efforts of the data analysis. Now, while focusing on its plumbing systems, volcanic ash, and explosive reconstruction, it's likely to explain the geological processes that leads to its hazardous activity and how this information is used for assessing hazard and attempting to mitigate it. Now, understanding the volcano's mechanisms, which is the internal plumbing system, how it works, specifically the processes of magma injection, storage, and the gas buildup, which ultimately drives the type of scale or eruptions. We try to describe the characteristics and impact of the volcano ash produced by the Popocatépetl's explosive eruptions, and how the study of these materials help scientists understand past and present activity, which is still going on today. By attempting to reconstruct its history, we explain how geological evidence, historical records, and ash distribution maps are used to reconstruct the volcano's history of edifice construction and destruction. Now, this helps determine the frequency of large magnitude events. The combination of topics aims to connect the fundamental science of how the volcano works with practical application of protecting lives and all in all the infrastructure as well. I've gone ahead and also included on the last slide references. I thank you very much for your time, and I hope I didn't speak too fast. Thank you and have a great night.